Here we're continuing solutions to the worksheet on sections 1.5 and 1.6. On practice problem 3 in class, we at least multiplied these things out, but we didn't actually finish the derivative. I said that at the time that we may want to first use our distributive property, FOIL, to multiply this out before we apply our derivative rules. And so if I do that, then I have first times first is 6x. I have the outer here is 3 times the square root of x, which we write as x to the 1/2 power. We know that's how we're going to need it for our derivatives. The inner is 4x to the minus 1 times 2x, which multiply together to just be 8. No x's at all. The x to the minus 1 times x to the first cancel each other out. And then finally, x to the minus 1, or 4x to the minus 1 times x to the 1/2. We add the exponents and get 4x to the minus 1/2. So if I apply my derivative rules to this expression, the derivative of 6x is 6. Then I have the derivative of x to the 1/2 is 1/2 x to the minus 1/2. Then the derivative of plus 8 is just 0, so there's nothing there. And then I need the 4 times, and then the derivative of x to the minus 1 is minus 1/2 x to the minus 3/2. So I can simplify this a little bit, because I can go ahead and say that 3 times 1/2 is 3/2. And I can say that 4 times, and I can say that 4 times minus 1/2 is minus 2. So this will be my formula for the derivative of this expression. The second one was much easier, because we said that if we factor out an x in the numerator and cancel it with the denominator, then the expression that's in parentheses there is the same as x squared minus 4x, and the derivative of that is just 2x minus 4. So continuing on this page, we in class did this problem both ways. We did not algebraically simplify to check the two answers are equivalent, and but that would be a good practice for the algebra to do so. But let me go ahead and do the two versions of these other two problems, just so that you see some solution of each one, and then if you want to try to show they're equivalent using algebra, that'll be good. For this problem, number 2, the algebraic rewrite version of this would look like this. This multiplication is just, I can just multiply it through that expression. So x to the minus 1 would get multiplied by the 4, the 2x, the 3x squared, and so on. So multiply the x to the minus 1 times each of those guys. So that'll give me 4x to the minus 1 plus 2. Again, the x and the x to the minus 1 here cancel out, so I'm just left with a 2. Then I have the 3x squared times the x to the minus 1. So that's 3x. So basically, multiplying by x to the minus 1 just reduces all of your powers of x by 1. And so then our derivative rules can be applied to this, and I'll have 4 times minus 1x to the minus 2 plus the derivative of just this constant 2 is 0 plus 3 minus 14x plus 3x squared. So that would be the answer if I did the simplify the expression and then compute the derivative. The other option is to use the product rule, which says that I would do the derivative of the first thing times the second, and again I'm just writing down what the product rule says, I'm not actually doing it yet, and then add the derivative of the second thing times the first thing. So I'm just writing what the product rule says, which is that I need to compute the derivative of each of the two expressions times the other expression. And so this will give me the derivative of this piece is negative 1 x to the minus 2 times all of that stuff, won't try to rewrite it here. And then add to that the derivative of this guy, which is 0 plus 2 plus 6x minus 21x squared plus 4x cubed times x to the minus 1. And again, this blows the thing up into something that's algebraically more complex than what we had up here, but it was easier to do. It was easy just to say each thing times the derivative of the other. So if I had to algebraically simplify it, I would probably prefer the first method because it comes out in a more algebraically simplified way. But if I just need the answer as quickly as possible, then the product rule would be the way to go. Finally, in number 3, I'm going to not multiply that out. If you'd like to do that, I think that's good algebra practice. But just in the interest of time in this video, I'm going to just write down what the product rule would give us. Because basically, the more involved the algebra is before you do the rule, before you use the power rule, the more beneficial it is to just use the product rule instead. So in this case, the product rule starts to become a better and better option. Oops. So I've written down my product rule. It is I have two expressions multiplied together, and I have the first one's derivative times the second, plus the second one's derivative times the first. So each one's derivative times the other. And this is an easy calculation. The derivative of the first thing here is 8x. And then the derivative of this thing is just 2 plus 5x to the fourth minus, here I have to be a little careful, it's the 6 will sit there and then get multiplied by 4/3, and 6 times 4/3 is actually 8, and then this power reduces by 1. So if you have more space, go ahead and do the steps, but what you should get for your derivative is 8x to the 1/3, and then that's multiplied by 3 times 4x squared. That's what the answers to practice 4 look like in each case using the product rule. When we use the quotient rule in practice 5, we already have done this one. We did this one with using the algebra first, but let's do it using the quotient rule. The quotient rule says that I'm going to get a quotient that involves the first thing times the derivative, sorry, I shouldn't say first, I should say the denominator. So the denominator times the derivative of the numerator minus the derivative of the denominator times the numerator. So again, it's each thing times the derivative of the other one, but now it makes a difference what order we do it in because we have a subtraction here. So if I'm not adding these, I better make sure I'm doing the correct one first. And the denominator in the quotient rule is just the denominator of the original problem squared. So now that I've written down what the quotient rule says, it's a very easy matter to actually do it. So I'll have x times, and then this says the derivative of x cubed minus 4x squared, which is 3x squared minus 8x, minus the derivative of x is just 1, all over x squared. And so this would be fairly easy to simplify. If I multiply this x through this expression and subtract this expression, then I'll be able to then factor out an x squared and cancel that out. And then you should see that that's the same as the answer we had on the previous page. Similarly, again, I'll just do these with the quotient rule to illustrate that. I have a big fraction, and I have the denominator times the derivative of the numerator minus the derivative of the denominator times the numerator, and all divided by the denominator squared. So whatever this denominator is, that gets squared. So that's the form of the quotient rule, and then it's very easy to find this derivative. Again, that's 3x squared minus 4, and the derivative here is 1. So it was an easy matter to perform those two derivatives and get a final answer. Algebraically, it's going to be a mess, but it's only a mess if depending on what we have to do with it. So we don't algebraically simplify these things unless there is some reason to. And we will see examples where there is a reason to algebraically simplify them. But right now, the rule of thumb is, don't do any more algebra than you have to. So once we do one more step here of actually filling in what these two derivative expressions are, then that will be the final answer, and there's no need to do more than that. And number 3, again, it'll look like the denominator times the derivative of the numerator minus the derivative of the denominator times the numerator. And then that's all divided by the denominator squared. So once again, doing this derivative and this derivative, finding out what those are, this will be 2x plus, and you have to do something there with x to the 1/2. And the same thing there. This will end up being a pretty big mess. It's salvaged a little bit by the fact that the square roots that come up here will kind of simplify with that square root, and then the same thing here. You've got square roots that combine here, and of course the square root of x squared in the denominator just becomes x. So this will simplify a little bit after you've computed the derivative. But again, if you don't have to simplify it, then it's better to not. Both of these last two problems can be done. These two can be done without using the quotient rule at all, because in this problem you can factor an x minus 2 out of the numerator. So in this case, the numerator can be written as x times x minus 2 times x plus 2. And when you write it like that, then you can cancel out an x minus 2 with the denominator, and then it becomes a much easier problem. Similarly here, you could divide the x squared by the square root of x plus, and of course you have 2 square root of x over square root of x, so that'll cancel out. So in a sense, you can factor out a square root of x from the numerator and cancel with the denominator. So in quotient problems, if you can cancel out a common factor with numerator and denominator, it greatly simplifies the problem. So if that happens, that's definitely a better way to go than the quotient rule. You can see that the quotient rule blows the thing up to make it very complicated, in which case then you have to do algebra to simplify it back down. So if you can avoid the quotient rule, that would be better. And in each of these 3 problems, if you're diligent about factoring out of the numerator and canceling the denominator, you will be able to avoid the quotient rule.